Hey,
All right, hello
everybody.
everyone.
Do it. Let's do this.
Hello
What's
everyone.
up?
Pleasure to have you here again with us. We're super excited to have you on the third session of the series of coffee breaks that we have around securing the SDLC around the JFrog platform. With me today is Bill Manning. Bill, do you want to introduce yourself?
Hi, I'm Bill. Nice to meet everybody. I am one of the solution architects over here at JFrog. I've been here for a long time, and I'm always excited to work with Asaf on this stuff.
And my name is Asaf Cohen. I lead the security solutions at JFrog, joined as part of the video acquisition. And today we're going to talk to you about supply chain attacks. What are those, and how can you protect against those? So let's start with a brief, I would say, definition history about the supply chain attacks. So if you look at the definition of what is supply chain attack, essentially is a technique which an adversary slips malicious code or even malicious component into a trusted piece of software. So let's take this sentence and definition and start to break it down into the different sections, understand what is common about the attacks that you see below. So essentially, you see that this is, even though we hear more about supply chain attacks these days, this is not a new thing. We hear about it more in the news around the SolarWinds attack that happened last year. But if you look back, you see that supply chain attacks started a long time ago, and there are different variants and different types of attacks that were conducted along the years. And pretty much every other year, you have this big news about the supply chain attack. And let's talk about why it's so risky and what caused this supply chain attack to be so in the news and so invasive and essentially under the radar when it comes to the infiltration attack. So essentially, the fact that you take a piece of software that you rely on, essentially you see this all over the time. When you create your software, you essentially trust the compiler. You trust the dependencies that you take from global repositories, and you essentially trusting the dependencies that your dependencies takes into your CI system while doing the build. So why do we see more and more type of those supply chain attacks, and why is it such I would say a vector that we see more and more these days? Is because that attackers and adversarials are essentially lazy people. I mean, they want to get into the network, into the target, with the least amount of work that would cause and gave them control in many footholds, I would say. And if you look at the Zerodium website, that is essentially a platform is a mark for vulnerabilities. You can see that on the upper side, you would see that a remote code execution on the Windows desktop would even cost you up to $1 million, which is a lot. And this is hard. And back in the days, were like 20 years ago, for someone to develop an exploit, it was, I wouldn't say it's easy, but it was doable, and relatively to today, it was easy. But given that time, it took some time, and you would see those exploits coming in here and there and being exposed into the world every other time. But these days, it's pretty rare. There are a lot of countermeasures, specifically around endpoint protection, such as the antiviruses, EDRs, the anti-exploits, and all of that. Microsoft hardening their kernel, and essentially Microsoft Linux. A lot of security solutions have been applied to protect the operating system and the workstation. Whereas if you see on the bottom side, you would see that vulnerabilities on Apache, Tomcat, web servers, and essentially open source software components are much more cheap because it's easier to get those. Essentially, you would see that those dependencies and CVEs that you found are essentially vulnerabilities on open source software components, and you see those all the time on a daily basis. More and more CVEs are found. So from an attacker point of view, if I would need to compromise a big corporate or a big company in order to gain access to their network, I can either spend a lot of time in trying to find an exploit for a workstation or a server, and then I would need to find the net, like to be in an adjacent network or some network connectivity in order to exploit this. And I would need to do it one by one. Whereas when I do supply chain-based attack, essentially I'm finding a way to put malicious code or trigger an exploit in some publicly available repository, and then I let those parties download and use this malicious software component so I can amplify my attack, and within one, I would say, effort of putting malicious dependency in a global repository, I can gain access to many, many, many companies and a lot of developers that utilize this malicious component. So it's low effort, relatively low technical skill when it comes to develop malicious component as opposed to doing exploit development. You can spread it around and you can pretty much abuse the relationship between companies, because when you develop and you trust a dependency, or when if I'm a company that I get a component or something from another vendor, you pretty much abuse the chain of trust that have between companies. For instance, for me, I have an iPhone, so essentially when I'm downloading a package from Apple, I trust Apple. But the same goes in between companies. When it comes with the certification of a company, it gets trusted. So essentially the approach from a security standpoint is to find a way to blend the code into the community. So it can be either by maliciously and intentionally putting a backdoor, such as a vulnerability that is not yet detected that I know how to exploit, which will eventually, if discovered, going to be turned into a CVE, or put like credentials, hard-coded credentials, and this is the backdoor. Another approach is going to be to use malicious code and just have a malware being injected as part of the dependency. And I hope that someone is going to run this malicious code and going to include this in their software that they build. So essentially, we're going to see when software attacks, what are the two main categories of attacks that are being seen today? The first one that I'm going to talk about is the dependency type exploiting. Essentially, it's a very simple yet effective way to get malicious code into build system and into software. If you recall the definitions from start, it says that you include malicious component or malicious code into your trusted piece of software. But you didn't notice that, and now I'm adding this comma, which is written by humans, comma, and so on. So the fact is that software is written by humans, and humans by nature sometimes have errors by mistakes. So if an attacker would upload to a global repository a software package that have a similar name that is similar to other publicly available, very known dependency, sometimes developers can mistakenly just have a typo and would use the malicious package and not the original one. And we had a publication that was found by the JFrog security team that found like around 10 malicious Python libraries in PyPy that have been downloaded more than 30,000 times by different developers. And this is like relatively simple. You would say it's a simple attack, but yet so many people have used this malicious component that eventually use this to extract secrets, credit cards, and a lot of information from those CI systems and from those developers. So you might think that, well, I would never fall for this, right? I mean, if I would have a typo, I would probably gonna catch this. So the fact is that you saw this can happen, and you need to have measures to protect against this. The second type of attack is something called dependency confusion. So with regard to third party, if I do a typo on the third party, that might happen. That's unfortunate, but it's a typo. It might happen. When it comes to my first party code, when it comes to my packages that I developed in-house, I feel comfortable. If I know the name and I put the name right, it shouldn't be a problem, right? So the answer is also no. Apparently, the most build system effectively get priority on the latest version, and they give priority to remote repositories over the private ones. So essentially, if somehow me as an attacker, I know an internal name of the package that is being used by Tesla, Netflix, whatever, because if I would take their body and I would parse it and somehow get the manifest file with the name of the internal package, if I would take the same package name, I would upload my own package to the global repository with a higher version. So they use version 1.1 or so. I would upload version 5. So at the resolution of the dependencies, the CI system is probably going to download and use the latest version, and a security researcher has done a POC about a year ago and was able to reach 35 major companies. And he did a test by having a dependency that would do remote code execution and would trigger DNS query back to his server, so he was able to identify. He got about $130,000 for this bounty, so that was very effective for him. And this is like the second time. Bill, do you want to take it from here?
Sure. So, one of the things that will be, the things that Asaf has been discussing has been, these are very coordinated. Some of these are sophisticated more than others. And we're talking about things like, in this case, dependency confusion, which is one of the other ones. And the idea here is that, maybe the actual version is slightly different naming convention, or, in this case, maybe they've upped a version. They included some additional package information inside, that might cause a problem. In some cases, it's actually not even the standard, direct transitive dependency, but it could also be an indirect dependency, right? Because 85 to 95% of your software is someone else's with those free and open source components. And one of the key factors here is that, how do you know this? I as a developer for many, many years, I have an inherent level of trust that I've done in the world where I've gone through and I've just assumed that if I find binary packages that I want to use to build my software, that they're safe. As we can see now, this is not the case. I mean, the primary use case in this is SolarWinds. Why was SolarWinds such a big heated thing? Why did people, freak out over it? Because not only did it affect 18,000 customers around the world, it's a multi-billion-dollar probably fix that's going to happen. But the thing is the way it happened was through a third-party indirect dependency. The Orion product that they had when they were building the software, there's a couple of libraries that they depended on for it. Somebody injected a malicious library into the actual stream of the other dependencies. It got pulled in, and then it was utilized. So, by the time it was actually exposed, it was too late. It came in as basically like a sidecar, just kind of came in with it. And, how do you defend yourself against that? Well, usually I would jump into our slide deck to kind of show off the pieces. But the thing is that if you're using Artifactory currently, there's already methodologies in which you can utilize to do this. If you're using our X-ray product, in addition with Artifactory, you have the ability to go in and actively scan not only binaries that are currently downloaded, used for your builds, but also too, preemptively, when those binaries are going to be utilized by your developer and giving your developer a little more experience. People use things like GitHub repositories daily. They can look at the GitHub repo, they said, oh, this is exactly what I need as my base level project, or, this is something I want to download and utilize. How do you know that's safe? So there's many different things out there that you're in this wild world of people who are really out to get you when it comes down to it, and you have to be safe and secure. So if you're using our products, I'm going to actually share my screen. I was going to do a regular standard presentation, but let me share my screen for a second to kind of show some of these pieces. So if we go in and I show you, we have the Artifactory products, and when we go in and look at Artifactory, let me get over to there, we can go in and utilize, let me log into the system for a minute. And, the thing is that when you are going in and actually utilizing Artifactory, one of the key factors here is that when you organize your repositories, you can, inherently build in a level of confidence that you're going to be safe and secure. So when you look at those third-party transitive dependencies that you have, and you could pick any one that you might want to do here, such as like maybe say NPM or something like that, and you define these repositories, you can go in and actually enable your ability to do X-ray scanning. And once you've done that, that gives you a look into all the pieces and components that you're utilizing. Now, I'm going to show you what it looks like from, say, a build aspect, where maybe I have something like even like a Docker container image, or I'm using something like NPM, or I'm using some other product, that I'm building, NuGet or any other resource. But as Asaf said, understanding these components that you use on a daily basis, how safe are they? So this is going to be one that's already actively in the system. And if I look at this component that I have here, our amazing JFrog research team dove into this and to look at the pieces behind it. They actually told in the standard CVE information. You know, it's a critical CVE. It's got CVS score of a 7.5 and a 9.8 on V3. That's pretty good. But one of the things I know about this is what do you do? How do you actually go to make sure that, you know, if there is malicious code, how do you combat it? So one of the main things you could do is that we provide remediation, understanding, you know, how you can quickly fix this, because the thing is that a majority of the issues you run into can be fixed by a simple upgrade of some of the actual components. But we also provide you with information on like summary details and also, you know, information around why is this an issue. But what if I'm a developer, right? You know, we hear all the time, we hear all these terminologies people talk about, things like shift left. Well, if you are using our product too, we have things like ID plugins. And with the ID plugins, I'm going to show you just really quick, here's another example. And I can show you in here that this actual NPM build that I'm working on here is using Artifactory, but I can go in and I have active information about those third-party direct and indirect dependencies that I'm utilizing. And I can go in and look and see if there's any issues and if there's any possible remediation and what is the cause of the problem. So if you want the maximum ROI and the maximum protection, you should always start at the developer level. You can also integrate it into your CI process and have it as part of your build process so that maybe something changed by the time the developer was working on it to the time it got to the CI. You can have it all the way down to the time when you finally release your software. But what if you're utilizing other things, such as, you know, I'm looking at other components out there, and I want to make sure that I'm looking at, say, a GitHub project, and I'll go ahead and I do a Git pull, and I take a look at the project I have here, and here's all the pieces. One of the nice things that we've done is that you can actually audit these actively. So having more active participation, in this case, I'm going right now, I'm looking at this actual resource I'm working on. I'm using our X-ray product, and this is going to let me actually produce a report to say, here's some of the components that are in jeopardy if you decide to use this. But, you know, the thing is that we also provide a level of remediation and things that you can do around that. And we have other things that you can do that we have. So in other words, you can use our JFrog build info when you produce and publish a build to see what are the contents of the actual builds you're doing, all those third-party transitives. You know everything about it. If you find an issue with it, you can track and trace it through all the builds that it's affected. You can also go ahead and look at how deep the vulnerabilities go into the processes you're doing. You can also go ahead and discover things like the blast radius. We have things called repo prioritization, which will lock a version into a third-party transitive, so if a new version comes out, you can evaluate it, and so it doesn't affect your system, directly. We also can have it so you have additional information around the software bill of materials on how it was constructed. Did it introduce a vulnerability at specific times? So when you use our platform, and the software is touching on some very good components, we have ways for you to go in and successfully try to combat them as early as possible as part of your SDLC, your software development lifecycle, all the way down to your release process. And then we can also help you do things like around root cause analysis. And some of the slides I'm showing here are just additional things we have, such as approval process with our JFrog pipeline product. We also have signed pipelines to make sure that when you're building things, that you have digital signatures representing, the build processes that you do and have accountability. And then at the end of it, one of the other things that we also do is you have a release bundle. So when you are releasing your software, it's a digital component that you can make sure that it's isolated and contained and have accountability behind that. I know we went a little bit over time and stuff like that, but Asaf, please interject anything you'd like towards the last part of this, because I think we are really brushing up against the razor's edge here on time. All right, Asaf, anything you want to add?
No, for mine, it seems like the bottom line is that JFrog platform can really help in making sure that you have secure by design approach and securing your pipeline, and you have those facilities even today, both at X-Ray as well as Artifactory, to protect yourself. So go for it and have the best that you can out of your product.
Excellent. Hey guys, thank you for joining our short talk today. Be safe, be well, and may the frog be with you.